Imagine drifting through the silent reaches of space, where galaxies slowly dance and stars quietly awaken. Here, the universe whispers its secrets, waiting for a calm mind to notice. Welcome to Relaxing Facts Studio, where we gently explore the cosmos, uncovering its hidden rhythms and subtle wonders. Every scene unfolds like a quiet story, from the glowing birthplaces of stars to the invisible threads connecting galaxies. Take a slow breath, let your curiosity float among the stars, and join us on a serene journey through the vastness of space, one relaxing fact at a time. Jets of light and matter shoot quietly from the center of a galaxy, moving near the speed of light. These relativistic streams push through surrounding clouds of cold interstellar gas, gently compressing them in ways that set the stage for new stars to form. You might notice that the densest parts of these clouds begin to collapse, a subtle process triggered by immense gravitational forces combined with the energy of the jets. Over millions of years, this creates pockets of star-forming regions scattered across the galaxy in patterns that seem both delicate and deliberate. The black hole itself, though invisible, regulates this cosmic rhythm. Gas falling toward the central mass heats up, radiates energy, and sometimes is ejected again, creating a quiet balance between cooling and heating that shapes how many stars appear and where. There's a slow underlying connection here between the growth of the black hole and the evolution of the entire galaxy. Larger central black holes often coexist with larger, more mature galactic structures, hinting at a long-term dialogue between the center and its surroundings. During periods of rapid star formation, known as starbursts, massive amounts of new stars ignite almost simultaneously. These stars forge the heavier elements, carbon, oxygen, iron, that will one day become part of planets and perhaps life itself. You can imagine these elements spreading quietly through space as stars live and die, enriching the interstellar medium in subtle waves. It's a continuous, unhurried cycle where immense forces shape delicate structures, and the presence of a supermassive black hole quietly orchestrates the birth of countless new stars across the galaxy. This cycle repeats over cosmic time, with each interaction between jets, gas, and gravity leaving a calm imprint on the galaxy's evolving form.
Galaxies drift through space, their stars tracing quiet paths that seem predictable, yet something subtle underlies their motion. Gravity bends the light from distant objects, curving the paths we observe, and through these gentle distortions, astronomers detect a hidden presence: dark matter. It does not shine nor absorb light, yet its pull guides the rotation of galaxies, keeping their outer stars from drifting away. You might notice that the stars at the edges move faster than expected, hinting at invisible mass holding everything together, a quiet scaffold shaping the cosmos. Beyond this unseen matter lies a more elusive force: dark energy, quietly accelerating the expansion of space itself. Observations of distant supernovae show that galaxies are moving apart more quickly than they once did. There's a subtle push at work, something pervasive and gentle that influences the entire universe over immense stretches of time. You can imagine space itself stretching, carrying galaxies along like leaves drifting on a slow current, while the light from ancient stars gradually shifts toward longer wavelengths, revealing the subtle hand of expansion. Experiments on Earth attempt to uncover these hidden components, using sensitive detectors buried deep underground, or observatories scanning the sky across multiple wavelengths. Researchers hope to identify particles or fields that compose dark matter, or better understand the nature of dark energy. Each detection, each measurement, adds a soft layer of clarity to a vast, mostly invisible structure, offering a quiet map of the hidden universe. The combination of these two unseen influences defines the large-scale shape of everything around us. Galaxies rotate, clusters form, and space stretches, all guided by forces that are present yet imperceptible, shaping the cosmos in ways that are slow, continuous, and deeply intertwined with the very structure of reality.
Earth drifts silently through space, its oceans and continents small markers in a vast cosmic neighborhood. Nearby planets follow slow, steady paths around the sun, each at distances that make even our local system feel immense. The gentle curves of their orbits, the faint glow of gas giants, the subtle rings of Saturn all create a quiet backdrop that stretches outward, revealing how expansive even the space immediately around us truly is. You might notice the faint light reflecting off distant moons, a soft reminder of scale and distance. Beyond the solar system, the Milky Way unfolds as a vast rotating disk, its hundreds of billions of stars scattered across spiral arms that twist gently through space. Dense clusters of stars form glowing knots, while dark clouds of interstellar dust drift between them, shaping the patterns of light we observe. The galactic center contains a concentration of stars, gas, and a supermassive black hole, a quiet anchor around which the rest of the galaxy slowly revolves. Farther still, billions of other galaxies appear, separated by millions of light years, each a sprawling system of stars, gas, and dark matter. Some cluster together in subtle webs, while others drift more isolated, their light taking millions or even billions of years to reach us. Astronomers map these distances using faint beacons like Cepheid variables and supernovae, measuring redshifts to gauge how space itself stretches over time. Through these observations, a picture of the universe emerges, quiet yet immense. Light from distant galaxies travels across cosmic voids, whispering of scales so large that Earth's neighborhood seems almost intimate by comparison. Every measurement, every gentle pulse of light adds a soft layer to our understanding of the vast, unfolding cosmos, a structure both enormous and endlessly fascinating.
Galaxies trace faint, elongated paths across the universe, forming slender filaments that stretch over millions of light years. These threads of matter are subtle but persistent, connecting clusters of galaxies into a vast, intricate network. At the points where filaments intersect, massive galaxy clusters gather, containing thousands of individual galaxies bound together by gravity. You can imagine these clusters as quiet nodes in a sprawling lattice, each glowing softly against the dark backdrop of space. Gravity slowly sculpts this cosmic web. Tiny fluctuations in density, present shortly after the Big Bang, grew over billions of years, pulling matter along invisible currents. Gas, dark matter, and stars drifted into these emerging filaments, forming the interconnected structures we observe today. There's a gentle rhythm to this evolution, with matter flowing gradually toward denser regions, while emptier areas expand and thin, creating a delicate balance across enormous scales. Computer simulations reveal layers of detail hidden to the eye, showing how vast sheets and strands of matter twist and curve in 3 dimensions. Models illustrate how filaments merge, split, and shape the environments of the galaxies they connect, offering a quiet insight into the forces that govern large-scale cosmic formation. Each simulated snapshot captures the evolution of matter from diffuse clouds to structured networks, mirroring processes that took billions of years to unfold in reality. Looking through this lens, the universe appears less like scattered points of light and more like a coherent, living architecture. Galaxies move along these gentle filaments, clusters form at intersections, and the cosmic web quietly stretches across the expanse of space, an enduring framework that shapes the distribution of matter and the unfolding story of the cosmos. Vast stretches of space appear almost completely empty, punctuated only by the occasional distant galaxy. These cosmic voids span millions of light years, forming enormous pockets where matter is scarce, yet their presence quietly shapes the surrounding universe. You might notice that these empty regions are not static. As they expand, they gently push nearby gas, dark matter, and galaxies toward the denser filaments that thread through space, guiding the large-scale arrangement of matter. Within these voids, the scarcity of stars and gas creates an unusual kind of calm. There is little interference from surrounding structures, and subtle gravitational effects dominate. Scientists find that voids provide a unique environment for observing dark energy. With so few objects inside, the expansion of space can be measured more directly, revealing the quiet influence of the mysterious force accelerating the universe. Every measurement across these regions adds a soft layer of understanding, tracing the interplay between emptiness and the fabric of space itself. Astronomers map these vast voids using extensive surveys, charting the positions of galaxies across immense volumes. Patterns emerge as outlines of emptiness, the negative spaces between walls, clusters, and filaments. These maps reveal that voids are not simply random gaps, but coherent structures that subtly influence the evolution of galaxies along their edges. Looking across these regions, you can imagine space stretching almost uninterrupted, a gentle backdrop against which the universe arranges itself. Matter drifts along invisible currents, collecting in threads and walls, while the emptiness between them quietly persists. There's a slow, pervasive rhythm to this process, a vast, continuous movement that shapes the cosmos in ways that are subtle, expansive, and deeply intertwined with the unseen forces guiding everything around it.
Material swirls steadily into the heart of a black hole, forming a luminous accretion disk that spins with quiet persistence. From this rotating disk, narrow jets of high-energy particles erupt, moving outward near the speed of light. These streams cut through surrounding space, interacting with cold clouds of gas and dust in subtle yet profound ways. Shock fronts ripple across the clouds, compressing them gently but persistently, nudging pockets of gas to collapse and begin the slow process of star formation. You might notice that these regions, once diffuse and quiet, gradually brighten as new stars emerge, their light stretching softly across the galactic plane. Observations across radio and X-ray wavelengths reveal the activity hidden at the galaxy's core. Telescopes detect the faint glow of these jets, tracing their path as they carve through interstellar space. Patterns emerge in the compressed clouds, showing where stars are likely to ignite next. Over time, repeated bursts from the central black hole leave a lasting imprint, influencing the distribution of star-forming regions across vast stretches of the galaxy. This process quietly reshapes the galactic environment. Areas once sparse with potential now become vibrant stellar nurseries, while older regions continue their evolution. Each jet, though fleeting on a cosmic timescale, contributes to the broader structure of the galaxy, moving matter, triggering creation, and linking the dynamics of the black hole with the rhythms of star formation. There's a subtle balance at work, a gentle dialogue between immense gravitational forces and the delicate clouds of gas that will one day become stars. Observing these interactions, it's possible to see how even the most extreme objects in the universe participate in the quiet, ongoing cycle of cosmic growth.
Dense spheres of stars drift quietly through the halo of a galaxy, their light faint but persistent. These globular clusters are among the oldest structures in the universe, remnants of early cosmic history that formed when star formation first began to flourish. Hundreds of thousands of stars move in delicate, gravitationally bound orbits, creating tightly packed systems that glow softly against the surrounding darkness. You might notice the subtle variations in density, the way stars cluster toward the center, while outer regions remain more diffuse. As these clusters orbit their host galaxy, they are gently pulled by the larger gravitational field. Tidal forces act slowly, stripping stars from the edges over millions of years. Each close pass near the galactic center intensifies this effect, gradually weakening the cluster's outer regions. You can imagine streams of stars drifting away, forming faint trails that extend across the sky, almost like cosmic ribbons marking the cluster's slow dissolution. These stellar streams preserve a quiet record of the cluster's journey, tracing paths shaped by both the cluster's original orbit and the gravitational contours of the galaxy. The survival of a cluster depends on its path, the density of the galaxy it orbits, and the cumulative effect of countless gravitational interactions. Over time, some clusters lose enough mass that they slowly dissolve,
blending into the background of the galaxy's halo. Even as they vanish, they contribute to the broader structure, adding stars to the diffuse halo and leaving behind subtle markers of their existence. Observing these dissolving clusters and their extended streams offers a gentle insight into the dynamic, continuous evolution of galaxies and the quiet processes that reshape stellar systems across cosmic time.
Invisible halos of dark matter envelop entire galaxies, stretching far beyond the shimmering disk of stars that we can see. These unseen structures provide a quiet gravitational framework, subtly influencing the paths of stars and the motion of gas throughout the galaxy. You might notice that even regions that appear empty are shaped by this pervasive presence, guiding stars along gentle curves that unfold over millions of years. Nearby galaxies drift past one another, sometimes passing close enough to interact. Gravity tugs softly but persistently, stretching stellar orbits, distorting spiral arms, and exchanging clouds of gas and stars between systems. These encounters leave lasting impressions, reshaping the visible structure without abrupt disruption, a slow choreography that gradually modifies the contours of galactic disks. Within each galaxy, stars themselves are not fixed in place. Over immense spans of time, they drift across the disk, moving inward, outward, or slightly above than below the galactic plane. This migration blends populations of stars, redistributes angular momentum, and subtly alters the balance of mass throughout the system. Patterns that might seem stable over human timescales are slowly smoothed and reformed, a quiet evolution that leaves traces in chemical compositions and stellar motions. Over billions of years, these combined forces, dark matter halos, gravitational interactions, and stellar migration, reshape the galaxy's architecture. Spiral arms twist, bars form and dissolve, and disks thicken imperceptibly, all without dramatic upheaval. The process is continuous, almost imperceptible, yet it defines the long-term structure and dynamics of galaxies. Observing these changes is a reminder that even what appears constant in the night sky is subject to gentle, unceasing transformation on cosmic timescales.
Gas clouds drift quietly through galaxies, slowly becoming less dense as the raw material for new stars diminishes. Star formation tapers off over billions of years, leaving older stars to shine in isolation, while fewer young ones ignite. The process is gradual, almost imperceptible on human timescales, yet it shapes the long-term evolution of galaxies, leaving them quieter and less dynamic. You might notice that spiral arms begin to fade and star clusters age, their light slowly cooling as new generations become rarer. As space itself expands, galaxies drift apart, moving beyond each other's observable reach. Clusters once close now become distant and isolated, separated by ever-growing voids. Light from neighboring systems stretches into longer wavelengths, dimming over time, and each galaxy appears to inhabit a more solitary corner of the cosmos. The universe gradually becomes a mosaic of isolated islands of stars separated by silent, empty expanses.
Black holes continue their slow, patient existence, consuming matter when available, but over trillions of years, they may gradually lose energy through processes like Hawking radiation. Even these immense objects are not eternal, fading subtly as the universe ages. Cosmologists consider several possible final outcomes for this vast expanse. In some scenarios, the universe approaches a heat death, where thermal energy is evenly distributed and no work or star formation can occur. In others, slow contractions or alternate expansions might subtly alter structure over incomprehensible timescales. Every model points to a future dominated by quiet, gradual changes, a cosmos where motion persists but creation diminishes, and even the largest structures eventually fade into faint, enduring remnants. The universe's long-term story is one of gentle transformation, an ongoing evolution of light, matter, and space, unfolding across unimaginable stretches of time.
Thank you for joining us on this peaceful journey through the wonders of the cosmos with Relaxing Facts Studio. If you haven't subscribed yet, click the subscribe button to stay connected and receive all our upcoming episodes. You can also support the channel by liking this video and sharing it on your social media, helping others discover these calm, immersive explorations of space. I'd love to hear your thoughts. Leave a comment about what stood out to you or the ideas this video inspired. With your support, Relaxing Facts Studio can continue creating relaxing, informative content and keep exploring the universe for years to come.